We're now going to be looking at cosine law and sine law. We're starting here with cosine law. So this is for triangles that are not based on 90 degrees. So we've been dealing with triangles for a long time that have been like that. And you could do a squared plus b squared equals c squared, the Pythagorean theorem, and you can do SOHCAHTOA. But one of the things you can't do is, what if the triangle is like this, where this angle is not 90 degrees? And so, I mean, that's a little extreme, but you can have triangles all the time where none of these angles are 90 degrees. So none of them are a right angle. And so we can still find sides and angles, but we're going to have to use different laws. Now, cosine law is a little bit more complex, and the sine law is a little bit easier. Now, before we do that, it's good just to remind ourselves how to put this stuff either into a calculator or using a trig table. All right, so it says here, let's take a look. Use a calculator to find the following. So sine 120, so you can go to, I mean, you can have a calculator, but we're going to use a trig table. Can I zoom out? Yes, I can. So I want to go to 120, which I think is on the next page. Anything over 90 is the next page. So 120 is here, and sine is the left. So 120, 0.866. So we can go over here, 0.866. And that's all we're going to do for all of these. So I'm actually not going to do all of them. I'll pause the video, I'll fill it all out, but then I'm going to move on. So let me just do one more, like the last one, cos of 167. So go over here, 167, cos is in the middle, so negative 0.974. So negative 0.974. Okay, so we're going to need to know this stuff for the cosine and sine law, but just looking things up on the table, I don't need to record myself doing that. Okay, so it's filled in here. I mean, keep in mind that that these ones that are 0.5, just 3 decimal places, you could have a couple of zeros thrown in here. I'm actually okay because it's an exact value of just 0.5 or a half. You don't need the zeros. However, you are more than welcome to put them in. Now looking over here, this is a little bit misleading because we haven't labeled anything. One thing I like to just remind is that this is the angle. All angles are capital letters. And when you have an angle, if you look directly across, that is lowercase of the same letter. So what we're going to be doing for sine and cosine law is we're going to be looking for what I like to call side angle pairs. And that means your A's or your B's or your C's. So these are a pair. Okay. Now the other thing is worth noting is that we can't label these as opposite or adjacent until we have a perspective. So this right here is going to be our perspective. So this is what we're going to be referencing or our perspective. And because this is our perspective, then when we look across, we call that the opposite. Hypotenuse is always the hypotenuse. That's always the one that's across from the 90 degree. And so you look at, from your perspective, you look at the opposite. That's what you're going to label opposite. Again, hypotenuse is always there. And then adjacent just means beside. So yes, adjacent, this is right beside our perspective. Now hypotenuse is also right beside, right? Here's your angle. There's 2 things that you're beside. However, we've already decided as a math community, we're going to label that one the hypotenuse. Therefore, we're just going to label this one as the beside one or the adjacent one. And then, of course, going across the way, that's going to be the opposite one. Okay, so keep that in mind. So let's take a look here at the cosine law. So a cosine law is a mix of Pythagoras theorem and cosine in order to work with triangles without right angles. So without 90 degrees. So without 90 degrees. So we shouldn't have any 90 degrees. Okay. What's really, really important is how you label this. Okay. So if you want to find C, then because you have to look at, there's 3 different options here. So if you want to find C, whether it's an angle or a side, then you're going to want to choose this one. So if you want to find C or lowercase c, you want to choose this one. How do I know? Because it starts with a C. If you want to find B, then you're going to use this one. So if you want to find B or B, doesn't matter, lower or capital, then you're going to have to choose this one. And it starts with a B. It starts with a B and it ends with a B. And that's really important. Same with down here. Starts with a C and it ends with a C. So that's how we know if you want C's, we're going to choose this formula. And of course the last one right here, this is good if you want to find an A or an A. And it starts with an A. So you're going to have to probably memorize this formula. Now the beginning part's pretty straightforward. If you're finding A, start with A, and then go B and C. So A squared, B squared, C squared. It's always B squared plus C squared, or it's always a plus. A plus C, A plus B, B plus C. They're always adding. Minus 2B times C times cos of capital A. So we're going to work with this a bunch, so you don't have to worry about memorizing it right now. And after we do a few examples, it should make sense. So these formulas are all the same. It's just that we're basically just changing the last. These are A's, and then we change them to B's. Then we change them to C's. And if I'm doing C, like here, if I'm choosing C, great, then all of these ones are A's and B's. If the middle one, if I'm those ones at the end in B, great, then all the insides are A and C. Everything but B. So that's how this is going to work. Again, don't worry about it. We're actually going to just do some examples, and it should make sense as we do a few, all right? Okay, so let's actually do this here. Find the distance across the lake from A to B. So the first thing you should do whenever you have a triangle is label all of the sides and all of the angles. Luckily, the angles have been labeled for us, so we can just label across. So this is here, so I'm going to label this as a lowercase a. And then here's B, so I'm going to label this as a lowercase b. And here is C, so I'll label that. It's actually already there. It's kind of hard to see. So I'm going to just label that as a lowercase c. So I've labeled it all. Now, it wants me to find the distance across the lake from A to B. Well, that has a side C, so we need to find C. That is our goal. We want to find C, so we want to choose the formula that starts with C. So that's what we want to do. Okay, well, I know that the formulas kind of have a pattern to them. So if I want the C, it has to start with the C, and it's actually squared, and it has to end with a cos of a capital C. And everything in the middle is A's and B's. So it's an A squared plus a B squared minus a 2AB times cos of C. So I can bring this up. Times cos of C. And that is the formula. Now, I need to find lowercase c. That is what I need. Therefore, I'm going to make sure I have A, have B, have A and B again, and I have capital C, which, remember, capitals are angles. So I'm going to do that right now. What is A, what is B, and what is a capital C? So let's take a look here. A is 25, B is 12, and capital C is a 62. So A is 25, B is 12, and C is a capital 62 degrees. So we can just now fill this out and solve for whatever we need to solve for, which is lowercase c in this case. So 25 squared is 625. 12 squared is 144. 2 times 25 times 12 times cos of 62 degrees. Okay, so then let me just write down here. That was 625 plus 144 minus 2 times 25, which is 50, and 50 times 12. Now, I don't really know what 50 times 12 is. I'm going to put the 50 on the bottom, because that way I have a 0 in the corner here. 0, and then 5 times 2 is 10. 5 plus the 1 is 6, so 600. Okay, so this is 600 times, here, right, this is timesing, times cos of 62. So where is that here? There's 62, cos is in the middle, 0.469. So 0.469. All right, so here we have 625 and 144, which we can add together. Now, a lot of people like to do and add those all up. However, we actually have to remember that BEDMAS says we need to multiply these first and then do the adding. But I'm okay to add those because they're off to the side anyways, as long as I don't touch that 600 unless it's being multiplied. Okay, so 6 plus that 7, 6, yeah, 69 minus 600 times 4.69. So again, I don't know what that is off the top of my head. So 0.469 times 600. I'll put the 600 on the bottom because then there's just zeros everywhere. And then the third one starts with 2 zeros. And 6 times 9 is 54, 36, 37, 38, 39, 40, 41, 24 plus 4 is 28. So I'm at 281,400 with 3 decimal places. So I gotta go 3 in. So I'm at 281.4. And then I can go ahead and I can subtract those. This is c squared and c squared. Okay, so 769 minus 281.4. So I'll put a 0.0 here. Can't do that. So that's 10, which is 6. And then 8 minus 1 is 7. Can't do that. Make that a 16. 16 minus 8 is 8. So 487.6. Okay. So obviously if you have a calculator, you can just do all of that manually. Now what I have to do is I have to get the c alone. And the only thing that's happening is that I have to square root both sides. Now when you do that, you'll get a plus or minus. But because we're talking about real life here, there is no negative distances, so I'll just do the positive. I don't know what that is. I don't know what the square root of 487.6 is. So if on a test, we would just leave it like that if we didn't have a calculator. If we do have a calculator, we can estimate it. Which in this case is kind of fun to do. Not fun, I guess, but like it's good to know what is the actual distance across that lake. So 487.6 rooted 22.082 meters. So that is the distance across. So obviously this took a lot longer because there was a bunch of manually multiplying and subtracting here. But the idea is that you choose a formula that starts with C, find all of the information you already know. So I already knew that stuff, plugged it in, and then just did some relatively simple mathematics. And the whole idea is to get C alone, but it was already alone. All I had to do was square root it at the end. So there's a lot that went on there. We're going to do some more examples in the next video.